Welcome, everyone. Welcome to the second episode of EPI Talks. This is our podcast. The first one was just a sound podcast, but today we have on video three of my colleagues who will talk about the press release we just issued. My name is Katarina Vukušić. I am the Dissemination and Communication Coordinator of the EPI from the University of Zagreb. And today with me are Vassilis Papaefstathiou from 4th in Greece, Jordi Cortina, our Linux specialist from SemiDynamics, and Filippo Mantovani, who is our HPC Center expert from the Barcelona Supercomputing Center. So today I will take advantage of their time and just ask them a couple of questions for our viewers to see on our YouTube channel about how EPI team managed to boot Epac 1.0 RISC V core boot Linux on Fpga. So welcome, guys. And we would like to start off with Vassilis, who I would like to ask, how did the Fpga emulation help in the verification and validation of the Epac memory and the cache system?
Well, in these developments of the API accelerator test chip, we are making extensive use of Fpga technologies to verify the RTL of the accelerator test chip. So we use these FPGAs to test very complex and real software packages in timescales that could not be tractable in simulation. So running the tests in full simulation takes days, where in the FPGA it can run in minutes or seconds. So that gives us enables us to work a lot faster and identify the problems a lot faster. Now, the interactions between software and hardware are extremely complex in the FPGA, and this thing allows us to test and expose corner cases that happen very rarely, and this is very important. And we have used actually this Epac FPGA prototype to run tests and verify the data integrity, check that the data provided by the memory and the cache system are correct and they are updated properly. And we have also tested and stressed very complex cache coherence scenarios and the memory consistency of the system by running litmus tests.
Okay, and how did the Fpga emulation help with the system software development?
Well, we have used this Epac Fpga emulation as a software development vehicle to test Linux configurations and prepare HPC-focused environments and software distributions. So we use this SDV to develop and test new code inside the operating system, develop low-level drivers for the Epac to support custom components and architectural extensions. And we also use it to run and tune complex HPC software packages like MPI, OpenMP, and combinations of the two. And on top of that, we have used such SDVs to experiment with I/O virtualization frameworks like VirtIO and to develop the associated system software for Epac.
Okay, thank you for that input. Now, I would like to ask Jordi, what do you think? What are the challenges of booting Linux on a new platform? What was it like for you, and how did you manage this?
So it's probably debugging all the issues that come up during the boot process on the Fpga platform. Linux is inherently a complex software which takes around 50 million instructions to be executed before it even gets to the prompt. So even for a basic kernel with no drivers, right? So it's during this process where the fun takes part. Because there's no visibility of the internals of the emulated design on the Fpga, in order to debug an issue found during the boot process, you have to come up with a list of signals from the design that you think might help you uncovering the bug. Hence, you need to route out wires out from the Fpga so they can be observed on the waveform. This is a very slow process, an iterative process, and it takes, again, several iterations before you actually manage to fix the problem.
And can you tell us why is that important? Why was the whole process important for the EPAC in general?
So being able to put Linux on Epac allowed us to run real software on real hardware. And this is a solid proof of concept that gives us the confidence that Epac is a functional and viable product. I guess that's the most important one.
Pretty cool, I would say. And Filippo, can you tell us something from the HPC side? So how can HPC take advantage of Linux operating on Epac?
Yeah, sure. Thank you. Thank you for having me and also for the questions. The important point is that basically we can now measure things. So we have a system that is booting a, say, standard operating system, and we can run benchmark software and benchmarks, and this basically allows us in the EPI consortium to measure the performance, measure the results, spot also bottlenecks and so on. And this has two main consequences. One is for the consortium, that is basically we are able to understand our architecture in action, and so we can model it and also project it for future generations or next generation, say, HPC architectures. And the second consequence is more for the community, that all the pieces of software that have been mentioned by Vassilis and Jordi, like Linux itself, or the MPI layers or other libraries that are open source, can be say, provided to the community, to the HPC community, and also to the RISC V community. So basically, this is a consequence that is probably slower than the first one. It probably won't be 100% our contribution, because it's a huge community, but still having a platform that is able to run a standard operating system allow us to contribute to the community. So from the HPC, say, data center point of view, I think this is the most important consequence.
And thank you. I have one final question for all of you. I do understand this was a team effort, but Vassilis is in Greece and the two of you were in Spain, if I'm not mistaken. So how did you organize working? I know people normally nowadays work from home and this because of this horrible COVID situation, but also our consortium already has 28 partners from 10 countries. What was your way of organizing this type of collaboration, and was it exciting? Did it provide any pluses or minuses to your joint effort? Any one of you can pitch in. Filippo?
I see Vassilis is starting.
Okay, Vassilis.
I say on my side that I think it works pretty well. It's a distributed team, of course, and there are many projects with distributed teams. But in our case, we have so good collaboration and close touch, and it works, and we are really effective as a team. Even though we use we're in different countries, different time zones, and stuff like that. But I think it works pretty well, and shows that academia and industry can collaborate in effective ways, at least in this project.
Yes. Okay. Thank you. If you guys have anything to add, sure. Now? No? Okay. Then I thank you all for sharing this insight with us, and I invite our viewers to come to our YouTube channel and subscribe if you want to see more of this kind of content or presentations from various events that we participated in, as we are hoping to enrich even more our digital repositories of content. Thank you all, and see you, I hope, in some sort of next episode of EPI Talks. Bye.
Thanks very much.
Bye.
Thank you. Bye.
Bye-bye.